In number 4, we're dealing with the same graph from before, y equals square root of x, but we have a different scenario, some different graphs to go along with it. So we have our square root of x, half of a sideways parabola, and y equals 2. So we're going to have y equals 2, that horizontal line, along with the y-axis. So the region that we're looking at this time is right in here. And this time we're rotating around the y-axis. Now this is a graph if we were just trying to find the area, we could use a dx cut or a dy cut, either one. But since we're going around the y-axis, and from what we've learned so far, our best option here is going to be a dy cut. And around the y-axis, using discs, we're going to have a dy cut. In the future, we're going to learn some other options that would allow us to use a dx cut, but for now, we need to use a dy cut. So we're taking that rectangle and spinning it around the y-axis. So if I spin this around the y-axis, we're going to get that cylinder, right? A disc, a flat cylinder. This is our radius, this is our height. Well, we've already established the height is going to be the dy. The radius in this case is going to be that x value. It's going from the y-axis to the graph. This horizontal distance would be x value on the graph. But since we're doing a dy cut, we can't write this in terms of x. We have to write it in terms of y. So we have to write this using y. So we need to know what's x equal to. Well, we know square root of x is y, but we want to know what x is. So we can square both sides. X is equal to y squared. So y squared is going to be our radius for this problem. So when we set up our integral, we've got pi times the radius squared, so the radius is y squared, and then we're going to square that, times the height, which is dy. And then we need to figure out our lowest and highest y values. Remember, everything has to be in terms of y here. So our lowest y value here, where the y-axis intersects this graph, is going to be at 0. And the highest y value is our horizontal line here, y equals 2. So really we have pi times the antiderivative of the definite integral from 0 to 2 of y to the 4th dy. Again, this is one you can punch in your calculator, but this would be one where you could be expected to do it by hand. So we have pi times antiderivative of this is 1/5 y to the 5th. We're evaluating from 0 to 2. So 2 to the 5th is 32. So we get 32 fifths. Minus 0 to the 5th is 0 times 1/5. So we'd have 32 fifths times pi. Again, you can do it with the calculator, but just as a refresher, in case this is on the non-calculated part of the test, that's how we would do it.